Let's talk about my topic. And let's talk about why it's my topic. And let's talk about why a typo has been on the start slide. Industrie 4.0, Industrie 4.0. It's not a typo, it's a German term. So it's somewhat interesting maybe why a German term has got such a huge attention during, now I would say, more than 10 years from now. More than 10 years from now. And it's my topic because I started to work in that field already before the term had been coined. I didn't realize it even, that I was working in the field. It took some years for me to realize that I was working in a field which was termed as Industry 4.0, and I didn't really understand what that was. And maybe it's the same with you. So I hope that I can give you some insights into that field. And the economic logic behind the digital revolution of manufacturing industries. So it's also about digital transformation and economics and business economics in special. I hope you can follow my style of language. Some say I have a marvelous accent without the slightest English, but nevertheless, I hope you can follow and attend. So what is the agenda for today? I would say 5 major issues I'd like to tackle. The first is, what is it about? What is meant by Industry 4.0? And sometimes it's called a digital revolution. So we will talk about that issue. Is it a revolution? Is it a kind of evolution? We will see. We will talk about the economic logic behind to better understand the concept. The second step will be, somewhat technologically, but only highlighting some technological issues around Industry 4.0, because as you might know, it's around the core of a firm, which is, what is the core of a firm? What do you think? When it's about the core of a firm, what do you think it's about? Well, it's about production. It's about production of real things. That's what a firm is about, isn't it? Depends. Some students of business economics think, well, the purpose of a firm is to make money, isn't it? Yeah, it's not about the production of money, isn't it? It's about generating surpluses. Yeah? But in the core of the firm, I would say there is production of products or services, we will see, but that's it. And Industry 4.0, as we will see, is around that. And of course, there's a lot of technology involved into the field of production. But I will try to convince you that it's not a technical issue per se, and it's not an engineering issue per se, but it's worth to discuss it as a topic of business economics. And then we will talk about why is it important. Why are we talking since 10 years from now about it? Well, it's about manufacturing for the future. We will discuss that, what is meant by that term, and then I will try in the fourth step to give you some playground, I would say, and mark some lines on it. So I will try to show you the fields of action so that you get some structure in the field, because I can assume that sometimes digital transformation, Industry 4.0 and so on, there's so much buzzwords around so that it seems, from my point of view, interesting and important to structure the field just to give you more oversight. And then, as you might know from my original field of expertise, it's about management, accounting and control and production. I'm mainly interested in questions which are being tackled in the 5th step. It's about investment and performance. Because the really tough question is, well, there are several tough questions, of course, around, but the really tough question is, there is so much money being spent for digital transformation. What is the return on investment? Is there a return on investment? Is it worth to invest in it? And where are the examples where we can learn from best practices? So that's it. And now let's dig in. Here, that's a photo taken at the Hanover Industry Fair in 2011. As I mentioned before, that was the fair where the term Industry 4.0 was coined. And since that, each year, the Hanover Industry Fair had that topic. Well, I didn't really realize what is meant by that in 2011 and even in 2012, I think. I still try to find out what do they mean by that. And I will show you how I found out what it is and how I found out that I was already in the topic for several years before. Why is it called Industry 4.0? I mean, why is it called that way? Well, it's about digital transformation of industrial manufacturing. So that's first of all. So why is it called 4.0? Well, it's pretty easy to explain, but it's also a little bit questionable, of course. It's just by numbering certain stages of the Industrial Revolution, which is already questionable, because it's questionable if there were such stages. We can discuss that later on. I will just show you that, which is here written in German, because the picture, that is the picture usually used, is the one which is in German. But I think it's pretty easy to follow. The numbering is easy. First, in Industrial Revolution, with the main issue, mechanization, which is usage of machines. With what purpose? To substitute labor by capital. The second Industrial Revolution was kind of also a division of labor, usage of electrical power, and so on. Fordism, as you might know, the entering of the assembly line in industrial production, and so on. What is the purpose here? It's again the substitution of labor by capital, but different, as you might have realized, from mechanization more to the electric power. Then we go further to the third Industrial Revolution, which is already the usage of electronics and the first computers in order to automate production, which has been around the 1980s and 90s already. So terms used at that time were computer integrated manufacturing, CIM. And now we are, as it is claimed here, in the fourth Industrial Revolution, which, and there is another term which has to be explained, about the usage of cyber-physical systems. Well, let's make it short. It's about combining the physical industrial sphere of manufacturing and production with the sphere of internet, okay? And up to 2010 or so, I would say there has not been really much discussion about how to combine these two spheres, because manufacturing and production has to do with real things, with the real world. And the internet, well, that's it. So that is why it's called Industry 4.0. I hope it's clear from now. And of course, we could discuss whether it makes sense to number certain stages. I would say it doesn't make sense from a scientific point of view. But of course, I would say from a marketing point of view, or just for strengthen a term or something like that, why not? But let me answer the point why I think it doesn't make sense scientifically. I would argue that the Industrial Revolution, which started around, one could say, 200 years from now, started with the purpose of substituting labor by capital, which is technology. And what we've seen over the past 200 years is that the usage of technology and technology itself always has changed. It's a dynamic, it's a progressive happening, and therefore I don't see why one could really senseful distinguish certain steps. I mean, these are examples, insightful examples, and they are used to number it, but I think that's it. So it's better we understand economically what it's about. It's about substituting labor by capital. And this, of course, if you follow the course of time, definitely has significantly changed the way of industrial value creation. And this has, by the way, changed the entire world. I mean, this picture is one of my most beloved pictures. It's not very, I would not say it has no color, yeah, it has no gimmicks, it's not funny, but it's impressive, isn't it? So what does it show? I mean, don't ask me about data gathering for getting the numbers, but you can read it in some economic history textbooks, as I quoted here, Clark. And what is shown here? Well, you see the income per person over centuries. And what you can see here is there was not much progress during the entire history. That was called in economics, and is still called in economics, the Malthusian trap, which is to say, well, an increasing population requires more and more food, which is hard to increase when the population increases faster than the food production ever could. And this kept somewhat life over centuries in a certain stable situation, which is not to say that it was a very wealthy situation. It was for most people in the world a pretty poor situation, of course, and that was the Malthusian trap. And as you can see here, 200 years ago, something strange happened, and that is now called the Industrial Revolution. We already talked about it. It was the usage of technology to substitute labor, which had enormous impact on economic growth. But one has to say, only in a certain part of the world, which we now call the developed world, which is a somewhat strange term, isn't it? And the other part of the world left in the Malthusian trap. This other part, sometimes called the developing countries, are trying to follow the path of the Industrial Revolution. And there are certain success stories, but there are also some shadows, of course. But I think that is pretty interesting because our discipline, economics in general, but business economics in special, stems from that great divergence because it was obviously necessary for businesses to grow, to have employees which are able to understand growing businesses. And that was a pretty new subject 200 years from now and still 100 years from now. So that's what we are talking about. The Industrial Revolution is an ongoing process since 200 years. It's still ongoing, and Industry 4.0 claims to be a major step in this ongoing industrial revolution. And, as I mentioned, the great divergence, which is to say there is a developed and a developing world, other countries are trying to pace. So let's have a look into some interesting historical data. What I show here is a kind of world production function, which is, again, we have the income, which is here the gross domestic product per worker, measured in 1985 dollars. And here we have the capital per worker, which is to say, well, what is the input into the production sphere of certain countries? And that is here, you could count it, 59 countries. They are shown in a certain state of time. The triangles are 1965 and the circles are 1990. And what you see here, these are the same countries, okay? You could compare them. But you see here there are a lot of countries here below, which is to say they are investing not so much capital in their production sphere, and therefore they get a small output. And there are other countries which invest pretty much capital into their production sphere, use a lot of technology to produce, and they get even more output. And as you can see, when you compare 1965 with 1990, well, it looks pretty similar here below, but in the right above, you see, wow, some countries have moved further and further, and that is the Industrial Revolution. Yeah? That is this kind of progress, which means if you stop acting in Industrial Revolution, you will fall back and others will overtake. So that is a dynamic process, and it's about competition. It's not only a national competition, as is shown here, it's also between companies, of course. What I show here now is a path, a historic path for Germany. Beginning in 1820, which is economically speaking in the Middle Age. Yeah? Which is to say, well, Germany started where they all started, with nearly no capital usage in usual production and manufacturing, and very, very small output. And this has massively changed during, now we could say, 200 years. But here is measured the path until 1990. And as you can see, Germany is, with several other industrial nations, a leading company in the Industrial Revolution, and Industry 4.0, therefore, is aimed at being the next step towards moving further and further. Okay, that is also to be understood as a national interest, as Industry 4.0 is also an initiative of the German government, which has been followed by many other governments as well. Here we can see the technical core we will talk about later on as well. It's about cyber physical systems. It was mentioned some slides before. What it's about? Well, I explained it pretty rough by combining the real sphere of production and manufacturing, real things, machines, material, products, humans with the internet, with some kind of data exchange. And why is that important? Why should it be important? Well, that's the key of my lecture, of course, so wait some seconds. But the question is how the internet and techniques of a usage of data exchange and so on in the production sphere, how can that make firms more productive in order to progress even further in the field? So that's what it's about. And this kind of combination of materials, machines, labor, software, data is not so easy for established production companies, as I will show you later on. So, giving a usual German lecture has to start with a definition, of course, doesn't it? So let's start with a definition. What is it? Well, I would try to describe it just to give you something you can chew on. Yeah? Industry 4.0, I would say, describes a form of industrial value creation which is characterized by automation, digitization, and connectivity. That's the internet part of it, of all actors which are involved in this kind of value chain, and which has impact on processes, products, and complete business models. And that's already the field I want to discuss with you. So how does increase of digitization impact production processes, products, and entire business models? Okay, that's, I would say, that's the field of action. But before we come to that, I would try to give you some idea why so many nations, governments, and firms think that might be important. The picture I show you here might be somewhat strange to interpret, but it isn't. It shows you always the same data, but always when you see the bold line, you see the mentioned country here. Okay? So when we talk about all the lines, these are always the same lines, but when we look into that chart here, then we see, the bold line, that's Germany. So what is shown here? Over nearly 30 years, we show here the share which has the manufacturing industry measured by the gross domestic product, which is to say how large is the manufacturing in a certain country. How large is the manufacturing sector measured by a total GDP? And you might remember that I would say when I say 20 years ago, you weren't even born, of course, but since 20 years, I would say, there is a kind of narrative which is to say, well, there's a kind of servitization, which means it's not about manufacturing real products. That's the old world. That's the old-fashioned style. That's not important. You have to invest into services. That's it. That's the future. Okay? And a lot of countries followed that path. And I will show you some of them. You can have a look, let's see, starting here, Argentina, Australia, and so on. But let's have a look to the United States. A pretty low share of manufacturing and decreasing all the time. And also United Kingdom. Okay? But when we have a look, for example, to Germany, we see a pretty large share of manufacturing, pretty stable over the whole time frame, and also China. Well, China has made itself to the factory of the world. So that's what you see here in the data. And Germany has a certain position as factory for the factory of the world, one could say. And some other countries didn't follow that path. Well, from today on, and there was a a massive financial crisis and even more crisis between, we have learned that it's too simple to say, well, manufacturing, that's old-fashioned. Forget about manufacturing, just invest into service and financials and insurance and all that, and let's buy the stuff from elsewhere. As you, from the current situation, know, that's pretty short-termed. That's pretty myopic, yeah? But it sometimes only needs a blink of an eye to change complete supply chains and so on. So I think it's pretty clear that manufacturing is important also for certain countries to have at home and not to outsource too much outside, because it's important to stabilize a whole economy and a society which offers a lot of income for several groups in a society. And even the United States struggled a lot, and all these countries, if we would collect new data on that, we would realize that a lot of those countries which decreased the share of manufacturing over decades started to change that process, to get some major industries back into their own sphere. Please.
Question: with the term manufacturing is meant turning resources into goods. So if you're like mining copper or oil or something, would this also be called manufacturing, or would it be a different?
No, that would be a different sector. Yeah. Okay. We start in manufacturing already by certain material which is already produced and not only digged out of a hole. Yeah. Yeah. Okay, that's it about. But if you want to start such a process or to restart such a process, it's important to know, how do I have to shape manufacturing for the future? How do I have to shape it in order to be competitive? And now we are back where we started. It's about the usage of capital, it's about the usage of technology. And which technology? Well, not the technology which made us successful for the last 10 or 20 years, but about the technology which will make us successful for the next 10 or 20 years. Because that is, I could go back now to the chart I showed you here. If you just would use the technology from 20 or 30 years ago, you are definitely not able to get into a position right above. Yeah, you're somewhere stuck with that kind of technology. That's always about investments into new technology, which has the potential to bring you further. Okay, and that's why this picture here and this kind of data just should show you that it's not only a German topic. It has been coined here, it has been invented here, this idea, as Germany has a has large stakes in the field of manufacturing, I would say. And other countries, I would say, have remembered their manufacturing activities and tried to pace up. So there are certain organizations and initiatives, I just want to name them. As you know, the German initiative was called Industry 4.0, and now you find the term everywhere in the world, and it is understood. In the beginning, the USA called their initiative Industrial Internet. In Japan, it was Industrial Value Chain Initiative. I mean, China had a huge, massive program which was called Made in China 2025. It's always a 5-year plan. We are interested to see what will be the next one. South Korea has something like that, Sweden, and I could go on talking about that, but that's boring, of course. Yeah, it's only to show you that is a worldwide initiative, but it's about competitivity. Yeah? Okay. So I already tried to show you the field of action or explain it out from my definition. So I think it shouldn't be a very large surprise now that we want to talk about the degree of digitization of products and of processes. And as you can see, the red arrow here now shows the field of activity in process digitization. The blue one is the product digitization. And of course, that's not a question of whether this or that. Yeah? It's of course a kind, you could show it as a continuum also. But I try to show it that way so that you could understand, well, the digital transformation for each company will be probably a combination of these two directions. And of course, we could discuss that if it's a good idea to show it in a four-square field, but we students of business administration are pretty familiar with two-dimensional pictures, I think. So I use this one also. But one could argue whether it's necessary to distinguish product and processes, as one could also argue that once you want to digitize products, you will have to digitize also processes. Yeah? But nevertheless, as I argued, it's indeed the combination of both which defines the strategy or just the path of digital transformation of a company, which is the yellow line shown here. When I came into the field and realized what is meant by Industry 4.0, I found the German discussion here stuck in that situation here, pretty below. It's about digitization of manufacturing processes. The discussion in the early years was mainly driven by engineers, and it was a hugely, mainly technical topic with no business aspects, I would say. This situation I found pretty scary. As I imagined, this is probably the way not to discover all the potential effects which are in the field. And so I started to do it more in the field of business administration. And it might be interesting for you that in 2014 we started to prepare, and then in 2016 we held the first Industry 4.0 conference for business administration here in Passau, right here. So now let's dig into the field of digitization of processes. What is meant by that? And well, it's important to grasp and have some feeling about, or some idea about, what is production about, what is production planning and control about, what's going on in a factory. Well, the picture I show here comes from one of our first projects, which was about the connectivity of certain actors within a factory. Well, it's also in German, sorry about that, because it stems from there. But there are machines, there are computers, there are certain people programming computers, have to secure certain quality standards, have to prepare machines, have to program machines in order to have them set up for the next order to be produced, and so on and so on. And you have to imagine a manufacturing firm which consists of sometimes hundreds of several machines. They are called CNC machines, which is to say computer numerical controlled machines. These kind of machines are known already since decades. You have to start programming by standing at the machine and typing in, like you type, or you did type into your calculator. Yeah, that's some kind of type of calculator there. And now there are some kind of other devices there. But these were standalone machines to be programmed and so on. And since decades, industry is working how to do the connection between all these actors. And you have to imagine the machine comes from firm A, the next from firm B, and from firm C, and so on. And they have all different data standards, and data is not easy to be exchanged between the machines, and so on. That's a huge, huge issue. This takes a lot of hours and workforce and so on. And what you see here, just shown by lines and dotted lines, well, each connection has to be programmed separately so that a kind of data exchange can be established. And just imagine if you have n machines and you want to combine each machine with another. That's pretty much, isn't it? If you do it bidirectionally, you have n square minus n connections, don't you? Yeah, you have. Yeah? And that's a square function, yeah? Which means there is a huge increase of needed connections with the number of machines. Imagine there is a software update. Imagine there is a new machine which substitutes another machine, and so on and so on. That's a kind of explosion of connections which have to be maintained. So this is what is shown here is not the solution of a problem, that's a problem. Okay? And that's where we came in. And our first project was about, well, let's do it that way. Sounds so easy, doesn't it? Yeah, it was not so easy. Because the project did define a new actor. You could say hub and spoke system. And the new actor acted as a software, which was able to get all the information required and send it where it is required. Yeah? And sometimes combine information, yeah, and send it to another actor, and so on and so on. And this kind of software has a name. It's called a manufacturing execution system. It's not about planning production. It's not about controlling production. It's about the execution of real production. And that's a pretty tough thing to do. As I mentioned before, as you have seen the complexity of that issue. So that is what this solution was about. And what we did in the project especially was to find out, well, if you want to have such a software, you have to invest a lot of money to get it. This company invented it. Yeah, so that cost millions, of course, because they just tried to solve their own issue. And then they got this solution, and then they tried to sell it for other companies. They just invented it for their own purpose, and then tried to use it also for other companies. So what we tried to find out as a next step was, what's the effect of that? Yeah, so that's it. Yeah, if you want to have a real example on what is Industry 4.0, I would say that's the way from here to there. So, and we wanted to know what's the effect of it. Okay, then we started pretty huge projects to find out how production processes change when you use that kind of software. It's not important for you to be able to read what is written here, but I want to explain it to you. What we did, we made process analysis in the current situation, which is shown above here. You see certain actors and certain process steps and so on. Pretty large numbers. It's only a part of it. I could fill all walls here with the pictures we made in that project. And then we made a kind of a plan. How would this kind of software substitute the current situation or change the current situation? Substitute certain actors, substitute certain steps, and what would change? And I mean, in the part below, you see some green fields, and these are where the manufacturing execution system comes into our sphere. And you could count now, and I did it for you, for a certain part of certain processes, that the current situation before using this manufacturing execution system, you could have counted 25 activities. 10 of them were with any kind of software, and 9 of them were manually, and 6 of them were where some employee had to make certain calculations or something like that. After using this manufacturing execution system, it was possible to reduce the number of process steps by about 40%. And as you can see, some manual steps remained, as it's usually in a real physical production sphere, but nearly all the rest was done by the manufacturing execution system. So that's pretty impressive, because the consequences of such a result is substitution of labor by capital. And not only that, there is also an increase in setup times, which is how long does it take to change a production system from one order to another. That's usually a critical task, because it's very important for the competitivity of a firm, especially when the number of variants is very large. Here also we were able to show that nearly 40% reduction of setup times was possible. And that's important for the usage of capital, because if you don't need so much time to change your machine system from one order to another order, then you can handle a large number of variants and do not lose a lot of time. And therefore you can use your capital efficiently. Okay, so I hope now you got some idea of our first project. And now I show you some other projects, some other processes which show a high degree of digitization. And of course, I'm always proud to have here our Passau example, my muesli, which also shows a highly automized and digitized production process for producing cereals. Well, they started on the other end of the line. They started where the customer usually is, and they designed a front end for an e-shop just to order cereals. But once they have been successful with that, they had to quickly change their manual production process to a fully automized production process, which is also located here, which shows, starting in that field, from the customer, the digitization runs through the entire value chain as it is shown here. Another example, which is again from the manufacturing field, is e-machine shop. There are several other examples out there, which is to explain it pretty easy. You can have a CAD program, as CAD means computer-aided design, which is integrated in such a website, and you can just design the part you want. Yeah? I mean, you are usually end customer, so you're not interested in any part you might build into a machine. But in the industrial sphere, that's it. I mean, that's the kind of supply chain logic. So usually you will not be the person ordering such a part as it's shown here. But once you understand what is shown here, it's the following. Usually you have to have a manufacturing system in your own company where you program for the production of such a part. And then you send this kind of plan to your machine, which is in your factory, and then it's going to be produced. But from now on, you can imagine that it's not necessary to have this kind of machine. It's even not necessary to have that kind of CAD facility. It's just necessary to have access to that website. And then you give your plan there, or you make it there, or you send it there, and then anywhere, a machine will start to produce your part, or the number required. Which is to say, from the other side, if you have machines, then it might be very interesting to have these machines plugged to the internet. Because if you plug them to the internet, then you can join this kind of competition. Otherwise, you can only produce products which come from your own company, but not those which come from other companies. And that's pretty important to understand why Industry 4.0 is so important. So I hope this gave you some idea what it's about, digitization of processes. And maybe the last examples were able to show you that it's not only about processes, it's about entire business model, because that is changing when we think these examples further. Now let's have a look to the product sphere, and which is here the blue line shown. I mean, that's the usual experience we have. Digitization is shrinking established business models. As I showed here, the music industry, which I was raised up with vinyl records. Yeah, I adored them. Yeah, black. Yeah, circulating around, making noise. Amazing. Then came cassettes, then came CDs, and so on, and you just awning about all that history here. It's not required anymore because digitization has vanished all that stuff, isn't it? Well, there is some, for such nostalgic guys as me, there is a extremely small market for vinyl records. Yeah, still there, still out there, but it's, well, it's a niche. Yeah? You cannot make a large business out of it. The large business has been grown out of this digitization by such companies as Spotify, Napster, and so on. So that's pretty clear, but that's a shock. That's a shock for an entire sector, which the music industry was. I mean, the same here with the, Quellekatalog. I mean, that was the internet for my generation, you know. when it was Christmas time, we were not using the internet. we were reading in the Quellekatalog. Yeah, I mentioned it in the German word, just to give you more nostalgic impression. The same with Brockhaus. Yeah, the same with SMS. Yeah, so digitization eats its own kids, one could say. So. But that's massive. When I entered the field, the first internet access I had was now 30 years from now. Well, it was pretty long. I'm a digital native, you are not. I am, yeah, I was there when it was born. And I must admit, I had no idea what to do with it, yeah. I got my first email address and there were some URLs, and so you typed it in and then you saw it, and well, and nice, but now let's go outside, yeah? Let's do some real things. And, well, I would say I saw a real change in the last 30 years. This stuff here, yeah? You don't require all that stuff. We had it. We were proud users of Sony and all that stuff they produced. We don't need it anymore. You just use your smartphone. You have better quality than those products ever were able to achieve. Not in the beginning. That's the disruptive element in it. But now, 30 years later, we could say it's better than these things ever were. But you have to look behind it. Here is an entire industry of electronic devices, which was disrupted by a completely other product and a completely other sector where it originates from. What it's about production, I said. Now, what does digitization of products mean? What is a digitized product? Well, let's start with a dumb product, as cereals are. And cereals probably will remain dumb products. So there are products out there which will remain in that way. And we have seen digitization of processes is the right way to tackle it. But there are products which you can make to smart products just by building in a system, embedded systems as it is called. So you build in a computer. That was not possible that way 30 years ago just due to technological reasons. Yeah, the systems would have been too large. Now they are even smaller and smaller. That's also a disruptive element. Yeah, the ability to decrease size of computers. Okay, once you have a smart product where a computer is integrated, then you can make it to a smart connected product, which is to say you can connect it to the internet, and then from that on you can connect it with others. And that establishes a product system. So the digitization of products is not only about smart products, it's about the smart connected products, which allows to create entire product systems by combining certain sources of data. And now there is another aspect which is enormously important to understand. Now we have players in the field which do not originate from the field of manufacturing. There are abilities which usually a production firm hasn't. It's about digitization. It's about digitization of products, about connectivity, about collecting data and making something useful out of data. And now we see, well, that's where the internet firms come around. And that's where they start to achieve the real sphere. Yeah? Some minutes ago we talked about Industry 4.0 is about cyber-physical systems, which is about combining the real world of production and manufacturing with the internet. But now we have to realize there are two directions. The incumbent manufacturing firm has to go into the direction of the internet, but also the internet firms go towards the direction of the manufacturing firms. And that's a new battlefield. Yeah, it's not only the manufacturing firms for themselves. Completely new players with huge abilities in the field of data gathering and doing something more or less useful with data. And probably they are much faster and more able than a classic manufacturing firm. Now, what can we get out of this? It's about collaboration. It's not only about competition, it's also about collaboration, which is to say it's important for a manufacturing firm to find out who is the best partner for me to get into the sphere of the internet. Because establishing my own capabilities would take too much time, cost too much money, and probably will not get to the same result than if I partner with Amazon, Google, or so on. Okay? But now that's a main result of a recent paper we wrote. So sometimes I'm driven by insights I'm carrying with me, and I haven't included into the presentation. But otherwise, it would take a week or so. No, that's not so good for today. So, what are the functions and capabilities? How can a firm digitize a product, and how can it do something useful with it? Well, there are some defined steps I refer to, which is you can just monitor what the product is doing right now. What is the current status of it? You can try to control the product usage. You can steer it. Yeah? It's about sensors and actors and so on. It's about optimization of usage. Once you are able to follow the current status and control the device, then it should be possible to optimize the usage. for example, to reduce energy consumption or something like that. And the fourth step would be to have an autonomous device which is able to do everything alone. So these would be options for the usage of smart connected products, but these options would require a certain business model, which is to say it's a service which has to be combined with a physical product. And from that on, I can give you just an example for any windmill or something like that, which are pretty large and pretty costly and so on. It's very important that this is running. And therefore, it is important to monitor its usage very, very carefully. And with the usage of artificial intelligence, it is possible to detect certain patterns in such a system, which can act as a weak signal in order to forecast a crash of the system, for example, in order to avoid that crash, and so on, which is also costly, of course. So in that kind of condition, monitoring and combined with a kind of predictive maintenance could be such a service, which could be offered by a supplying firm of such windmills, for example. And that changes the entire business model of physical or real product producing firms. If you imagine, if you sell a machine, that's a classic transaction. Once it breaks, you fix it. Okay. But you can do in the next step, you can offer a service contract. You can say, well, we give you some kind of warranty, and once there is something going on, we will fix it, and you don't have to pay it. You have to pay, of course, in advance, because the service agreement costs you some bucks. Then you could offer a product service system which offers the client an optimized usage. Well, that's a kind of calculation he has to do. If I reduce my costs, I could pay some extra bucks for that service. And the next or last step or current step, I would say, is product as a service. As you might probably know it from the software field, as Microsoft Office is usually now sold as software as a service. I was raised with a CD, or no, it was diskette, of course. Oh, sorry about that. You had to put into your computer and then install all that stuff. And now it's software as a service. But this also holds for real products. Therefore, you wouldn't buy a product in that sense that you buy the property of it. You just buy the usage of it, and you pay for the usage of it. And it would be possible, of course, for the seller to guarantee 100% usage. Otherwise, you wouldn't have to pay, of course. And this is something strange, because it changes the entire business model of a classic firm. Usually, they make their sales by selling products, which means a lot of money once the machine is sold. And when it's over, then they're waiting until it's broken, yeah? And then they fix it, and then they make a lot of money again. But if you change it into a product as a service business model, you don't make as much money at a certain point of time, but you have to change it over the time. Yeah? That is something different, but there are some famous examples, of course, known since years, which is, for example, Rolls-Royce engines for airplanes. Not the luxury cars, but the engines for the airplanes are since many years built in an aircraft, but they are not sold, they're just used. And if you use the airplane, then you pay for the usage to Rolls-Royce. That's the same with some other firms. But I think that's important to understand. By that change of business model, you can start, and that's important to understand, then you can start to sell not only the usage of a product, but also the service which is combined to that product, which is established on smart connected products. But once again, I would like to stress the need for being able to collect necessary data, to have the products in the internet, to be able to get the data, combine it with other data, and make something useful out of it, which is usually called, well, it's about data analytics. And usually it's a kind of data pool or data lake, which is the term used, which is used for the description of data, the diagnosis of data, the prediction of future states which might occur, or the prescription, which is giving hints or advice what to do, how to make a certain decision. And that is, again, what I mentioned before, where collaboration seems to be very important for manufacturing firms, as building up such capabilities is not as easy as one might think. Before I run out of time, I should come to my investment and performance part, but just to remember, I try to give you some impression of or idea of what is the field of action of digital transformation, and I hope it's useful for you to better sort in certain activities. So now let's rush into my last chapter, which is investment and performance. And well, it's not so new at all that investments into information technology, IT, computers, and all that stuff is increasing, and investments into basic industrials are decreasing, not in absolute numbers, but in relative numbers, which is to say, a lot of money is spent for IT and all that stuff around. So now let's make a quiz. Science is not made for voting. Science is therefore very undemocratic. We cannot have a vote on certain scientific knowledge, but we can try to do so hypothetically. So what do you think? I just would like to show you some slides here where we have the relationship or hypothesized relationship between IT investments and the performance you can get out of it. Okay? So that's the idea. What do you think is the relationship between investments into IT and performance? And that's the crucial question once you decide, oh, is Industry 4.0 a good idea? Should we invest a lot of money into it? Let's see. What is the relationship? I mean, every manager would ask such a question, wouldn't he? Okay. So what do you think? Is the relationship that way? It's linear? Maybe. I show you some others. And then you can choose which one fits best. Is it maybe progressive, which means, well, you have to invest heavily until you achieve certain performance outcomes? Or is it degressive, which is to say, well, already the first euro spent will bring you some fruits? Or is it that way? Is it that's more sophisticated, isn't it? It's a sigmoid function, yeah, S-curve. That's very popular in technology management and innovation, isn't it? Maybe it's sigmoid, yeah? So you have to get over a certain threshold, and once you're over, then you achieve all the fruits. And above a certain threshold, well, you can continue, but it won't be very sensible to do so. So these are my options. You could design some others, of course. These are not all. But what do you think? Let's make a quick vote. Who thinks that this is a good approximation? Okay, thank you. Who thinks progressive? That's it. Okay, I see 4 or 5, 6. Who thinks it's a degressive function? 1, 2, 3, 4. Oh, it's even more. Thank you. And, well, now the sophisticated. Who thinks that's it? Oh, some. Yeah, some. So here, between degressive and sigmoid, that's it? Okay. And all the others, what do they think? No, I think you all voted. Yeah? So, you want to know what the answer is? Okay. What we voted was hypothesis. So if you do research, yeah, you have to have a hypothesis. What might it be around? Well, usually you have to have a theory. We haven't one. We just used graphs. Sorry about that. Yeah? But I'm not here to write a paper with you. If you come to my chair, we could do so. But once we have a hypothesis and a theory on that, we have to collect data. And once we collect data, then we can check what it's right or wrong. And that's it. Here you have the answer. That's the question. And that's the answer. The relationship, there is no relationship. Okay? And this is that's a puzzle, I would say. That's a puzzle. It's when you start researching and searching for some papers on it, you will find it called the Solow paradox, or Solow's paradox. Robert Solow, a great name, of course. Robert is great, isn't it? It's a Nobel laureate, and he questioned already 40 years ago whether all that money spent for IT is increasing productivity. I mean, you can be a Nobel laureate and write a book review and you get the most cited paper ever. Yeah? And here Robert Solow did so. He just wrote a book review about a manufacturing book. And the last sentence, I think, carries it all with it. You can see the computer age everywhere, he wrote, but in the productivity statistics. So he questioned whether it is measurable. He questioned whether there is sufficient data to show that all these IT investments increase performance. And of course, from that on, hundreds of researchers worldwide tried to find out whether that was the case or not. And they are still doing, and we also did. So now let's come back to this Solow paradox, which is, of course, not to say you should not invest into IT, yeah? Because, of course, obviously, there is an efficient frontier. Yeah? Of course, there are companies which get a lot out of their investments into IT. That's what we can see. So the conclusio, I would say, couldn't or shouldn't be, don't invest into IT. But I would say be careful with investments into IT. Be very careful, because as you can see here, there are a lot of firms below the efficient frontier. And they're obviously wasting a lot of money, and you shouldn't do so. And there is a huge industry around which is selling IT and software and all that stuff, and they're making a lot of profit out of Solow's paradox. Okay, once you're in that sector, fine. Solow's paradox is your treasure bin, I don't know. Yeah? But once you're on the other side, it's about losing a lot of money. And that's what you shouldn't do. Here is one study which is pretty recent and pretty interesting. It shows IT-induced productivity gains in the US manufacturing industry. And what you can see here, that's the blue line. Well, obviously there is some significant productivity increase, IT-induced. That's the key issue of the paper, how to measure IT-induced productivity increase. And you see the confidence interval, that's the dotted blue line, so it's like an alligator's mouth. Yeah? But you see again the Solow paradox already there in the confidence interval, because you see on the lower level there is no productivity gain, but you see on the upper bound, obviously there are some firms pretty successful in doing so. And on average, one could say the blue line, well, on average there seems to be a IT productivity gain. But now, be careful, that's the total manufacturing sector of the United States. Once you exclude the computer producing subsector, then you remain here, the red line, and there isn't any productivity increase anymore. So that's pretty clear. The computer and IT producing industry is, of course, manufacturing, but they are selling the stuff. The others buy. Those who sell the stuff have the increase, and those who buy the stuff haven't. That's a problem, isn't it? So be careful with digital transformation. Yeah? Of course, there's a lot of interest in selling the stuff, but obviously, and it's not me to say it would be nonsense to buy that stuff. No, that's not the case. It's the case how to invest properly, how to use IT properly and not to waste too much money. I mean, that's the hard question, I would argue today. And I just use my last seconds or minutes for that, just to give you some ideas. And that's about a paper we also wrote on my chair. And it was more or less a review paper about all the papers written around Solow's paradox. We wanted to know, what do they find out? What is the reason? What's going on here? That there, obviously, empirically, no productivity increase can be found or measured. I just want to mention certain headlines now, and if you want to dig in deeper, just read the paper. The first reason is it's hard to measure IT-induced productivity gains. That's really hard. That has a lot to do with the kind of cycles and skewness, and especially time lags. Time lags between introducing a certain technology and getting the gain out of it. So this kind of measurement issue, I would say, is very prominent in that discussion, and therefore it's worth reading it and understanding what it's about, because it's always important, if you want to invest into a certain technology, to understand there might be a time gap, and then the fruits will come. But never forget, in the management accounting sphere, we call this kind of expectation sometimes a hockey stick effect. So it's becoming worse and worse and worse and worse and worse. And yeah, at the end, it will become better and better. But it looks like a hockey stick, you know? It's always going downwards, downwards, downwards. And it's always kept in the future where the gains will come. Okay, especially we have adjustment delays, which is if you change from one technology to another, you usually have this kind of S-curve sigmoid function expectation, which is to say, well, the old technology gets you to a certain level of performance, and once you switch to a new technology, it's not to be expected that you immediately get back to your level, current level. Usually, you have to step back a little bit, because you have to learn how to use the technology properly, and it again requires some time to go ahead. So that's kind of learning curve effects and all that stuff, and especially the change of the required skills, which change with technology. And keep that in mind, because the ability or the capability of technological usage is as much as important as the technology itself. And this will lead you to my conclusion already. It's not a krimi here, it's a lecture, to keep that in mind. And this is because that's the investments into capabilities is often forgotten, neglected, or has not the prominence that the investments into technology itself. Okay, then there is a other problem or issue, that's exaggerated expectation. Well, that's a management issue, isn't it? To have exaggerated expectations. It's about 10 years from now, we are talking about Industry 4.0, and you all have to do it, and start right now, don't wait too long, yeah? The gold is waiting for you, and all that stuff of IT marketing, which probably is the most successful marketing field I know. Yeah, you don't realize them very much, but they are very successful in selling their stuff, having Solo's paradox in mind. Yeah? Well, I could name some other sectors, but I refuse to do so now. So we have this issue, which of course leads probably to waste of money, clearly. And then there is mismanagement, which is a very interesting, very under-researched topic to better understand that it's not only about following IT fashions, okay? It's sexy to invest into digital transformation, so we will do so, and so on. Just following a narrative leads you to a proper usage of your investment. Yeah, and there are so many problems. I really could list them. Managers are unaware of how to use IT properly. There is missing alignment of IT with strategy. That is a huge problem. IT usually isn't budgeted. In that sense, it's just bought. Yeah? And once it costs double price, doesn't mind, we have to buy it, because otherwise the machine stops. Yeah? So that is a huge problem, that so much money is spent for IT, but it isn't used properly. So low understanding of IT risks. I mean, probably you have read in the news 2 days ago or so, agricultural machine producer Fendt stopped production immediately due to a cyber attack. And obviously, you have a huge problem in-house. I just pull out this one. I would say IT investments are a money pit. That's from my management control perspective. I would say once you do not budget it, then it is definitely a money pit. Once you understand that IT projects are usually very ill-defined projects. Ill-defined means, well, you decide to have SAP in your company. Okay, let's start with SAP. What can SAP do? Well, sign the contract and we will explain. Well, they sign the contract and then they start explaining. And then usually the projects are being shaped and so on, but money already flows. Yeah, you're already paying for consultants and all that stuff, and you're paying and paying and paying. So IT, once it isn't budgeted, is a massive money pit, and this leads to investing too much money and not getting out enough, which is not to say you don't get out something good out of IT. Yeah? Of course you do, but as in any investment calculus, you have to calculate whether the gains are larger than the costs. Okay? And the last aspect in that review we discovered is the importance of complementary investments, which is to say the line from the IT investments to productivity is crossed by certain external factors. It's the type of IT investment, it's the existing IT resource, it's environmental factors, but it's especially complementary organizational factors, non-IT factors, which are very important to understand. That's the organizational structure, the skill levels of workers, management practices, management commitment to IT, and so on and so on. This kind of investment has to be seen as a necessary parallel investment to IT investment. And once that is not sufficient, then you cannot use IT properly. So that makes IT resources valuable, I would argue. And I would, on the other side, argue, be aware, disregard of complementary organizational resources may cause IT resources not to be used efficiently and effectively, as I try to work out with respect to Solo's paradox. And of course, there is much I had not the time to discuss with you, so you can read it. On the left, you can see our review paper I mentioned before, and on the right, you see a massive handbook, not only articles from me and my chair, but also from many other colleagues from the field. Unfortunately, Springer Verlag decided to have it in German, probably as a kind of competitive advantage for the German industry. I don't know why. But for those of you who are able to read certain articles in German, I would invite you to read it. So thank you very much for your attention, and now have questions.